Hi, welcome to another video short, and today we're going to be talking about continuity, or more specifically we're going to determine where the function f of x that equals a sine of 2x minus 5 divided by e to the x minus 1, we're going to determine where this function is continuous. Now when you get a question that asks you to determine where a function is continuous, the best approach is to actually try to determine where the function is not continuous. That is, locate any discontinuities, and then we will exclude those from our domain for our solution. Now, this is quite an interesting question because visually you probably have no clue what this graph looks like. So we're going to have to apply algebra as a technique to assist us in solving this problem. Now, when you obtain a question, as in this one, when you have a quotient, you may notice that the numerator, that is the sine of 2x minus 5, itself is a continuous function. And the denominator, which is e to the x minus 1, it also is a continuous function by itself. And one of the previous rules that we had discovered is that if you have a quotient of two continuous functions for all x in the domain, therefore the quotient, that is f of x, itself is going to be continuous, with the only exception is that where the denominator equals 0. So that tells us we are going to just apply some logic in determining where my denominator, that is where e to the x minus 1 equals 0. Now, this is a very easy expression, and most of you have already recognized that, hey, e to the 0 is 1, and 1 minus 1 is 0, so x equals 0. But if you didn't recognize that, algebra will guide you into obtaining that answer for x. So I'll just house clean. I'll bring the minus 1 over to the other side. Now I'm trying to solve for x, but it's hiding in the exponent. So a mathematical tool that allows you to bring an exponent from the roof back down to the ground is logarithms. And because I see an e, I'm actually going to use the natural logarithms to make my life a bit easier. So I'll take the natural logarithm of both sides. Now on the left side, I can use my properties of logarithms to bring the x right in front of the natural logarithm. And the natural logarithm of 1, of course, is 0. So this gives me x times the natural logarithm of e. And the natural logarithm and e are inverses of each other, so that's just equal to 1. So I get x times 1, which is x. And therefore x equals 0. So this is the only location where my graph has a discontinuity. Now, it's also a good practice to try to determine what type of discontinuity this is. Now, because we were not able to factor out a variable term that has the x in both the numerator and the denominator, that is, we didn't have a removable discontinuity, this guy has to be an infinite discontinuity. Therefore, the question which says determine whether the function is continuous, we know that this function is continuous everywhere except when x equals 0. Now, I'm just going to present the graph of this so we can actually see where we have an infinite discontinuity. A bit of advice. Sometimes it's very difficult to recognize if both the left side and the right side go to positive infinity or to negative infinity, or in this case, one goes up, one goes down. Just look at the sign of our expressions. Now, when x is bigger than 0, e to the x minus 1 is going to be a positive number. And sine of 2x minus 5 and x equals 0, the sine of minus 5 in radians is a positive number. So positive divided by positive is positive, and therefore when x is greater than 0, the function goes up to positive infinity. But when x is less than 0, again, sine of 2x minus 5 when x is about 0 is positive. But e to the negative number is a small number minus 1, which is a negative number, so I get a positive divided by a negative, and therefore my function will go down to negative infinity. Hopefully this was helpful for you. Thank you for watching.